All right, welcome everybody to Lab Day, week 3 Lab Day. So, what we're going to talk about today, this recording is just going to teach you how to count numbers in Mandarin and Japanese. You're going to need to know how to do for loops. You're going to need to know how to make a variable. You're going to need to know how to do input and output. You're going to need to know how to do if statements to get this to work. Okay, but the fun thing is you get to learn Japanese in this assignment, and so Japanese actually borrows from Chinese. Technically, it doesn't borrow from Mandarin. It borrows from a pre-Mandarin dialect, but it doesn't matter. The basic system of counting in Japanese, there's a Japanese system of counting, there's a Chinese system of counting. We're going to be doing the Chinese system of counting. So it's going to be beneficial if I show you the Mandarin system first. So let's say we count from 299 to 301. And so the way that both Mandarin and Japanese work is you say hundreds digit, 100. Tens digit, 10. And then the ones digit. Okay? So you can see here that 300 is san, which is, in Mandarin we go, er san se wu liu qi ba jiu shi, right? 1 through 10. So san is 3. It's also 3 in Japanese. San is also 3 in Japanese because it borrows. It's the Chinese system. And then we have bai. And so this is 300s. Okay? And then this is 300s and 1. San bai yi. And then for 299, we say 200s, 9 tens plus 9. Okay? If we do 1, 2, 3, 4, then 1, 2, 3, 4 is 1 thousands. So it's very regular. It's just 1 thousands, 2 hundreds, 3 tens plus 4. So thousands digit, thousands. Right? You guys understand that? So it's very the John Cena meme. Yeah. So that's the Chinese system of counting, which was then imported over into Japan. And anytime somebody in Japanese class is like, all right, why is Japanese like this? You know, why is there a Japanese system and why is there a Chinese system? Because aren't we learning Japanese? There's always like let's go back to the year 800 explanation, and then they have to give you the history of Japan to answer the question. Let me show you the Japanese equivalent. So 299 to 301 is 2 hundreds. So hyaku is not bai. Hyaku is 100, but it means the same thing. It means 100. So we have 2 hundreds, 9 tens, 9. Okay. So 2 hundreds, 9 tens plus 9. 300 is 300s. 301 is 300s plus 1. So in Japanese, ichi ni sanchi go shihachi kyuju. But when you're doing this assignment, let's just print the numbers from 1 to 10. Ichi ni san, instead of saying shi, you say yon, because it's more polite. Shi sounds like death. Omae wa mo shinderu, right? And then instead of shichi, which also kind of sounds like death, people say nana. Okay, so it's ichi ni san yon go roku nana hachi kyuju from 1 to 10. These are your digits. Okay, and so if we were to do 1, 2, 3, 4 in Japanese, then we say 1,000, 200, 3 tens plus 4. Okay, so sen is 1,000, and the other one was qian, and this one it's sin, not qian, sen. Instead of bai, it's hyaku, but it's basically the exact same system. But Japanese has a little wrinkle. Okay, you won't run into any irregular numbers prior to 3,000. So just start off, when I recommend you guys do this assignment, start off by just, can I print the numbers from 1 to 10 in Japanese? That's what I want to see you guys do today in lab time. Okay, I've given you a Japanese dictionary. Looks like this. And so you can see I've given you all of the Japanese words you need. You're going to need to vet your input and things like that. I've given you a die function that will kill the program. So in order to kill your program, you just type die, right? So check to see if the input's bad, see if the number's too small, see if the number's too big. If it is, die. Okay, you don't have to retype every time. If not cin, C out, bad input, return 0. Last time, a lot of students got tired of all the different error checks. Now all you have to do is say if the number's too big, die. If the number's too small, die. If not cien, die. Okay? So that will definitely help you. So this thing here is something called a vector. This is your first time encountering a vector. And what it is, you can think of this as a dictionary. So this vector here has all of the Japanese digits from 0 to 9 in it. And then this one contains the powers of 10 in it, which is not lined up using this font. So let's do that. Okay. Yeah, whatever. Okay. So how do you output one of these words? Okay. If you wanted to output the number 6, you could see out digits dot at. This is new for today. 6. Okay. So a vector is like a bunch of variables that live together under one roof. And you can grab individual members of the vector by using dot at, and then you pass in which slot you want. So if you want to see out Roku, this here is going to output Roku. You say digits dot at slot 6. The slots start at 0, not 1. 0. So slot 0, slot 1, slot 2, slot 3, slot 4, slot 5, slot 6. So this is going to output Roku to the screen. You can also, let's say, string s is equal to digits dot at 1. And so you don't just have to see out them. You can store them into another variable if you want. So what value is s going to have? If we are loading from our dictionary here, digits dot at 1. What string is held in digits dot at 1? Ichi. Good. 1. As it turns out for this one, the slot and the meaning is exactly the same. But for the powers of 10, they're not. So powers dot at 2 would be sin. Okay. So if we were to see out powers dot at 2, this is going to print sin to the screen. If you've ever seen Sin to Chihiro, the famous Studio Ghibli film. So, what if we wanted to print the numbers from like 1 to 0 to 9 to the screen? We could do this. You could. I don't recommend it. Do you guys see any better way? Oops, this one too many. Do you see any better way to print 0 each Nisanchi Goro than just copying and pasting 10 lines? Is there anything we worked on this week that might help you here? Yeah. You can do a for loop. Okay. And so if we did a for loop to print out the numbers from 0 to 9, instead of all this stuff, we could just do this. For int I equals 0. Remember the pattern. I is less than 10. I plus plus. See out digits dot at I. Comprendez-vous? You guys understand? So the first time through the loop, I is 0. It prints out 0. Next time through the loop, I is 1. It prints out Ichi. Next time through the loop, I is 2. Prints out Ni. Next time through the loop, I is 3. Prints out San. So on and so forth. Okay? This isn't going to work past 9, right? Because a lot of students, by the way, in the noon section, were like, well, why don't I just, go all the way? Like, let's just print out, the first 100. And so the problem is there a slot 10 here? Is there a slot 11? Is there a slot 50 in this vector here? No. So if you try doing this, it will print out 0 through 9 and then crash. Nicely, but it'll crash. It'll be like, you tried accessing element 10 and there isn't one. Okay? And so what you're going to have to do is use the powers of algebra. You're going to have to grab the tens digit. So like if you're going to print 55, which is goju go, right? If you want to print the number 55, you have to grab the tens digit 5, and you have to grab the ones digit 5. Maybe I should have picked a different number, 52, let's say. Goju ni, right? So how do you go from 52 to 5? How do you get the tens digit out of a number? Anyone know? Using powers of algebra? What can you divide 52 by to get 5? 10. That is correct. So if you have a two-digit number, you divide it by 10, that'll give you the tens digit. So 71 divided by 10, 7. Remember, this is integer division. There's no decimals. There's no fractions. 85 divided by 10, 8. Okay? So you can divide by 10 to get the tens digit, and then you can look up. Yeah. Well, slot 8, 85 divided by 10 is 8. Slot 8 holds Hachi. So we can print out Hachi, Jiu, and then what I say, 82. Hachi, Jiu, Ni. So how do you get the ones digit? So if you have 82, how do you get the ones digit? The 2. Like 82 what? How do you go from 82 to 2? Modulus 10. Very good. So 82 modulus 10, because 10 divides into 82 8 times with a remainder of 2. So division gives you the 8, and modulus gives you the 2. Okay? And that's what I'd like to see you guys get done by today. If nothing else, at least have this, because it's literally on your screen right now. So you should be able to print the numbers from 0. Well, not the buggy version, the correct version, right? You should have at least this because I'm giving it to you, right? So by the end of today, I want you being able to print, the numbers from 0 to 9 on the screen, and you're going to ask the user, right? You're going to ask the user, what number are we starting with? What number are we ending with? And what's the step size? The step size is, like if we go from 0 to 20, counting by twos, we go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. In elementary school, this is called skip counting. Have you guys heard of this before? Like counting by twos, counting by fives, right? So if we count from, 0 to 100, counting by fives, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, right? Counting by fives. You guys understand? That's what we call the step size. How much the counter goes up every time we iterate through the loop. Got it? All right. So, so there's a lot of points on this assignment also come from the error checking you might have seen earlier. I had code up there. I'm probably going to blur that out just because it's like kind of the answer for like 2/3 of the points on this. So probably in the recording I will put a little YouTube, nudity blur over it so you can't see the exact same thing, the exact code rather. But basically every time you input a number, like the starting number, you have to make sure that they didn't type in squirrel. Do you guys remember how to check to see, right? So you're going to make an integer like int start equals 0, cn into start. How do you check to see if they typed in squirrel? Or a non-number. Somebody is unmuted. Who is that? Nick Curley is here. Awesome. All right. Nick Curley's unmuted. Not cn. That is correct. So if we say if not cn, die. Okay. So if they type in anything that's not an integer, then you can just call die now. You don't have to keep repeating yourself over and over again. But if it's this, cout bad input, return -1, nah, not anymore. You just have to call die. Okay. Die kills your program. In order to get started, you should delete these 4 lines of code. The static assert here will stop your code from compiling. This is in here so that for any student who hasn't worked on their code at all, it makes it very easy to auto-grade. What happens? Your code doesn't compile, done, you get a 0. Okay, so to begin, you need to delete this line right here. And then I just wanted to, actually, Nico, you probably know the answer to this. Is Nico here? Yeah. So there is a famous character that says, die, die, die. Maybe somebody else other than Nico can chime in on that. Yeah, so Nico here is a Reaper main, so yeah, there you go. Ain't no way. No, I'm messing with you. Corelli is a Reaper main, so don't fear the Reaper. Ash, okay, nice. I mained Symmetra for a long time. Symmetra uses lightning sentry guns, which is another thing that Blizzard sort of copied from me. And imagine being the squad div main. I wanted to like Farah because like Farah uses the hover boots that I wrote, and the ult is kind of from my mod too. But you were playing Overwatch when it was fun, yeah. But this is just a Reaper reference here. So just delete these 3 lines. Die, die, die. And it tells you, like, delete these 4 lines of code to get started. So I just had to put in the Overwatch reference there. Okay. So how else, what else can be an error? If they type in an integer that's too small, die. If they type in an integer that's too big, die. Okay? The smallest number we allow is 0. The biggest number we allow is 1,009,999. So if they type in a number smaller than that, die. They type in a number bigger than 1,000,000 and change, die. And that's true for the starting number, for the ending number, and for the step size. Except the step size can't be 0, right? Because if you have a step size of 0, how much do you go up? 0 every time. So the first time through the loop, you print 1. The second time through the loop, you add 0 to it, you print 1. Next time through the loop, you add 0 to it, you print 1. It's an infinite loop. So the step size can't be 0. Otherwise, it's the same for start, for end, for step. And that I think is enough to go on. Do you guys want to see any? Oh, you want to see the irregulars, right? You want to see where does the pattern break down? So the reference has all this information for you, but let's say we go from 29999 to 3001. So it goes from Nisan, that's 2000s, 999 up to San. Now you might think it should be San Sen, because Sen is 1,000 in Japanese, but it's San Zen. Okay, there's a rendaku in that. And Japanese has rules. It's not exactly irregular, but it has rules for how sounds change if you make a compound word. So put your hand in front of your mouth and say casa, like house, except in Japanese it means umbrella. So casa. Do you feel the air coming out of your mouth? Casa. Yeah. You're learning Japanese and CS at the same time. You are. Yeah. Now, that's spelled casa. Okay. But if you make it a compound word, like sun umbrella, it becomes hagasa, like that. So say gasa, casa, gasa, casa. You see with the K, the air's coming out. With the G, it's not. Okay. And there's some term for it in linguistics that I forgot. A fricative. I don't know. I'm not a linguistics person. So there's a pattern in which when you make a compound word in Japanese, a H turns into a B, a K turns into a G, S turns into a Z, I think, or is that backwards? She turns into a G. Yeah, there's like, or a G turns into a she. And saying it backwards. Anyway, there's a pattern for how the rendaku system works. And so these things look like they're irregular, and they are. You're going to have to put in if statements for it. You're going to have to say if the thousands digit is a 3, then you can't say san sen. You have to say san zen. Okay. And oh yeah, there's irregulars in the hundreds also. Only numbers below 100 are regular. There are irregulars in the hundreds also. So so if we say 299 to 301, Nihyaku is 200. So 200s, 9 10s, and 9. Then it's San Byaku. So again, it's the rendaku thing where the Hyaku turns into Byaku. H turns into B. K's turn into G's. So on and so forth. Okay? So it's San Byaku. Let's see, 599 to 601. So 6 is supposed to be Roku Hyaku. Roku Hyaku is really awkward to sound. Roku Hyaku. And so it just turns into Ropyaku. So you see how it sounds easier? And so all these things, like there's a reason for them. They're not like 18, in English, or 16, or 11. Like, where the hell is 11? It should be 1 teen, right? Or 12 teen, or 2 teen, or what. Like in English, like we just straight up have irregular words that don't follow a pattern. But in Japanese, all of these, irregular words, there's a reason for it. And the reason is it just sounds better, right? So 3, 6, and I believe 8. So if we go from 799 to 801, we say nana hyaku, so that's regular 700s. And then you go up to hapyaku, which is, again, hachi hyaku is really awkward to say. Hachiaku. So it just turns into hapyaku. Okay. The README file lists all of the irregulars. I recommend not worrying about them right now. All I want from you guys right now is to print the numbers from 1 to 9 in Japanese, 0 to 9 in Japanese, and then work on the numbers from 0 to 99. Okay. So 300, 600, 800, yeah. And then in the thousands, there's 3,000. Hasen is 8,000. So 7,999 to 8,001. So it goes from Nanasen, which is 7,000s, to Hasen. So it's not Hachi-sen, it's Hasen. Okay. So the README file lists all of the irregulars. There's like 6 of them, something like that. It's not the end of the world, but it is harder than Mandarin for that reason. Mandarin has no irregular numbers at all. It doesn't have 2 different counting systems. It doesn't have 2 different ways of pronouncing, the characters. Japanese does. Japanese has a kunyomi and the onyomi, which is the kunyomi is a Japanese way of pronouncing a word. It has the onyomi, which is the Chinese way of pronouncing a word. And then sometimes they have like 7, and so when you see a character, you're like, oh, that's cool. I know how to pronounce it. Then your tutor's like, no, you used the wrong pronunciation. It's like, So Japanese is notably harder than Mandarin. In fact, on the first day of Japanese, Nico, do you remember this? Kosasa sensei was like, if you want an easy class, go take Mandarin. And everyone laughed. And then 75% of the people dropped by the end of the semester. We got wrecked. So everyone's like, ha ha ha, jeez. No, Mandarin's actually a lot easier than Japanese. Mandarin is literally the easiest programming language. Mandarin is the easiest human language that I've ever learned. I've studied 5 languages. Mandarin is far and away the easiest. Mandarin is a joy to learn. It is very easy to learn. It looks scary. It looks impressive. It's super easy. Japanese is ridiculously difficult. So, Sensei picked on you. Yeah. Kosasa Sensei picked on Nico a lot, but he stuck with it. He finished the class. 75% of the people in that class dropped out. We started with like 45, and we finished with like a dozen. And not all of the dozen passed. So it was like being in the firing line with just people getting shot down like left and right. It's crazy. Mandarin is the easiest programming language. The tones, it takes a couple weeks to learn the tones, but that's it. Like, the tones are all regular. There's no conjugation. There's no irregular like anything. There's like 2 particles, maybe 1. Like, la is like really the only particle that matters in Mandarin. And the other ones are kind of used in dialogue, like that kind of stuff. But Mandarin is super easy. Japanese is not. It's really hard. So I hear Korean's a lot like Japanese. I learned the Hangul. I learned the alphabet for Korean so that I could read the names of people in my Taekwondo class. Because when you're teaching, all the names of the students are written on their collar in Korean, and so I had to learn Hangul just so I could be like, Joseph, yeah, come over here. All right. So that is your assignment. It is in a directory called Watery, and you guys basically got an hour to work on it. I just want to see forward progress. Okay, screenshot it to me when you're done. And there's a board game club meetup at 4 at the college, AC2 182. We got board games tonight, 4 to 8 p.m. I will be probably leaving here at 3:50. So, but if you message me, I'll see it on Discord, and I can give you your points for lab time. All right, recording off. now.